All right, so here we go. We're working our way through this wonderful world that is radicals, and we're getting now to multiplication. So before we even begin, this is what matters. Root 3 times root 3 equals 3. A square root times a square root is whatever the root is, because think about the square root of 16 times the square root of 16 is 16, because that's 4 times 4. That's the whole point. So if you have a root times itself, the roots cancel, and you just get that number. Also consider fractions. That's root 3, that's root 3, same exponent. You have 3 to the 2 over 2, which is just 3. Okay, radicals cancel each other out when you multiply the same one together. So here we go. Order does not matter in multiplication. So you can do this however many ways you want. I'm going to show you this first question in 2 ways. So this is 2 times 5 times root 6 times root 3. I've just changed the order to put the roots next to the roots, which is 10 times root 18. But that's 10 times root 9 times root 2, which is 10 times 3 root 2, which is 30 root 2. So sometimes when you're multiplying two things together, you might not be able to simplify the one radical, but once they're multiplied together, you can. So the other way to look at it would be to break the radicals down first. So that's 2 times root 2 times root 3 times 5 times root 3, which is 2 times 5 times root 3 times root 3 times root 2. And like I just mentioned above, that equals 3. So 30 root 2. So, second one. Negative 3 times 4, negative 12. But then you have root 2, root x, root 3, root x. Well, what did I say? Same root. So you have negative 12x, and then the 2 and the 3 can't do anything, so we just combine them. Negative 12x, root 6. So it's pretty straightforward when we're just dealing with single values. But what about now when we have multiple terms? So I'm going to start by doing the distributive method. And the distributive method is water bombing this into here and into here, and then this into here and into here. If you're very astute, you'll notice that that's exactly the same as FOIL. I'm just using a different. I'm not going first, outside, inside. Well, technically I am going first, outside, inside, last. Sorry, I'm lying to you. The distributive method is when you take this entire thing and you multiply it into there and into there. Otherwise, we'll use FOIL. But first, let's do the distributive method. So you have 2 root 3 minus 3 root 2 times 2 root 3. And then you take the plus from here, and it's 2 root 3 minus 3 root 2 times that positive root 2. And then you water bomb in that, and you water bomb in that. So the distributive method is not as nice as FOIL, which you'll see in a second, but it has its place if we're not dealing with binomials. So now 2 times 2 is 4. Root 3 times root 3 is 3. And then 2 times 3 is 6. And then root 3 times root 2 is root 6. And then we're adding that to 2 root 6 minus 3 times 2. So now you'll see we have 12 minus 6 root 6 plus 2 root 6 minus 6, and you combine what you can combine. So 12 minus 6 is 6, and these are both root 6 terms, so minus 4 root 6. And we're done. Now if we were to do FOIL, it'd be first, outside, inside, last. So we had root 2 root 3, 3 root 2 times 2 root 3 plus root 2. So first, 2 times 2, 4, root 3 times root 3, 3. Outside, you get your plus 2 root 6. Inside, you get your minus 6 root 6. Last, you get your minus 3 times 2. So 12 plus 2 root 6 minus 6 root 6 minus 6. And you can see it's exactly the same. You get the exact same answer. 6 minus 4 root 6. So you can use either one. But can't use it on questions that are larger, and I'll show you some in the practice later. So what about when you don't have the same root index? That involves us using the relationship between radical and exponent. And you're going to have to do this because they are simplifiable, but sometimes we just need to do a little bit more work. So this first one, the fourth root of x squared, well, we know that that's the same as flower power x to the 4 over 2, which simplifies to x to the 1/2, which just simplifies to root x. Way more straightforward than the square root of x to the 4th root, right? Now for this one, you have x to the 3 over 2 times x to the 1 over 3. Now we may not have a common denominator, but we can get one. Common denominator is 6, so this becomes x to the 4 over 6 times x to the 2 over 6, which gives us x to the 6 over 6. Well, would you look at that? No, sorry, I'm like, that's too easy. I made a calculation error. 3 over 2, we're multiplying by 3, so this becomes 9 over 6. And 2 over 6, which gives us x to the 11 over 6, which gives you x to the 6 over 6 times x to the 5 over 6. So you have x times the 6th root. Now, that might not look simplified, but you've multiplied these things together and it's more simplified. Division, similar setup, but now we're dividing. So you have x to the 1/3. You have x to the 3/2 over x to the 1/3. So again, we're going to get a common denominator. It's going to be x to the 9 over 6 over x to the 2 over 6. But now we're subtracting, so you get x to the 7 over 6, which is x to the 6 over 6 times x to the 1 over 6. So that is just x times the 6th root of x. Okay? I know I might make them look straightforward because I do them quickly, but you can watch this multiple times, and I'll make small additional videos for key points too. So be aware of those. Next up, rationalizing the denominators. So what does that mean? Well, that means when the denominator is irrational, it has a radical in the denominator, and we just don't generally like that, right? Because we try to be as rational as possible. So if you're looking at that, it's like, no thanks. So what we're doing, like rewind all the way to grade 9, is we're making an equivalent fraction. We're making an equivalent fraction that isn't radical in the denominator. So we're going to multiply by root 7 over root 7, because that's going to give us root 14 over 7, which is the exact same value. It just looks different. It doesn't have a radical in the denominator. Now here's where it gets a little bit interesting. If you have a higher root, you can see the example there, but the difference is I used the cube root of y squared. Well, why did I do that? Because think about these as exponents. You have 2 to the 1/3 over y to the 1/3. And I need a full y on the bottom. And if I'm multiplying, I'm adding exponents, I need a 2/3. And I need a 2/3, which is the cube root of y squared. Because you need to make sure that that bottom value gives you y or whatever to the power of 1. So be very aware with those types of questions. And then the last thing, pretty awesome, has to do with FOIL, is when you have a setup like this. It's like, well, how do I rationalize that? Well, I want you to think about your difference of squares. remember that if you multiplied that with that, you would get this. And that matters because it's perfect squares, because the outside term, the first term and the second term both become squared, and there's no middle term, right? There's no AB, because normally we'd have like an A squared plus 2AB plus B squared, depending on what we were foiling. We don't want this middle term, because if my A value and my B value are radicals, I'd still have radicals in my question. So we multiply by the conjugate, which means you take this exact same thing, but you write it as the opposite sign. And again, this is equivalent fractions, so we got to multiply top and bottom by the same thing. So you'll see what happens here. First, we can do the top, totally fine by me. The 3 water bombs into there and into there. And you'll end up with 6 plus 3 root 5. But now on the bottom, you're doing FOIL. And you'll see why this is great, because 2 times 2 is 4. 2 times root 5 is 2 root 5. 2 times negative root 5 is negative 2 root 5. And then root 5 times negative root 5 is minus root 25. So why does this work? Because it simplifies to 6, 3 root 5 over 4. This cancels with this, which is exactly what we wanted, right? That's this bit going away. That's why we use the conjugate. And then 4 minus 5. So you get 6 plus 3 root 5 over negative 1, which simplifies to negative 1 times 6 plus 3 root 5. You can factor 3, so negative 3, 2 plus root 5. So this pulls like everything we've learned from grade 9, grade 10. Now you might be asking, wait a minute, negative 1, like times, you're dividing. Yeah, but remember that dividing by 1 and multiplying by 1 are the same thing. And this could be just 1 over negative 1. That's what this could be. And we just move the negative up there and 1 on the bottom. So you're totally allowed to do that. Or, if it helps your brain, it's 6 divided by negative 1, 3 divided by negative 1. But you just pull that negative out, right? Let me be very clear. I don't want to confuse people. 6 divided by negative 1 is negative 6. 3 root 5 divided by negative 1 is minus 3 root 5. You can factor out a negative 3, and you get 2 plus root 5. So same answer. Depending on your fluidity of your mathematical skills, you will see that a different way, but it's all allowed. So one more example, then we're done. Multiply by the conjugate. So root x minus 1, root x minus 1. But now we're going to have to do some FOIL. So you're going to have root x minus 2 over root x plus 1. And put brackets around it because it helps you keep it contained as an item. Just helps your brain. So FOIL the bottom and the top. So root x times root x is x. Root x times negative 1 is negative root x. Root x times negative 2 is negative 2 root x. Negative 2 times negative 1 is plus 2. So that's the top. And on the bottom we get x minus root x plus root x. Now when you get good at this, you don't even have to write these step down, but we're going to, right? Cancel, cancel. So on the top you get x minus 3 root x plus 2 all over x minus 1. So you've rationalized the denominator. So a lot in there. Multiplication. Have fun. Quite a bit of practice here. We got 1, 2, 3, 4, 5. A lot of practice. Okay. Enjoy.